Welcome to the next installment of my video lecture series in economics. And in this particular video lecture, I'm going to be taking a look at how to identify which country has the comparative advantage in a particular item. So the question is, the countries of Orion and Scorpius are small mountain nations. Both produce granite and blueberries. Each nation has a labor force of 1,000. The table below gives production per month for each worker in each country. Assume productivity is constant and identical for each worker. And there you have a table of information, and what this tells us is that each worker in Orion can produce 4 tons of granite in a particular month, and that same worker can produce 12 bushels of blueberries in a month. If we take a look at Scorpius, we can see that the typical worker in Scorpius can produce 6 tons of granite in a particular month, and the same typical worker in Scorpius can produce 12 bushels of blueberries in a month. So the way I normally tell students to do this is set up this as an equivalence. Let's just take a look at one worker. This is a typical worker, they'll always say, if we took one worker in a month, they could produce 4 tons of granite. That same worker could produce 12 bushels of blueberries. So in the time that they produced 4 tons of granite, they could have produced 12 bushels of blueberries. So let's say in that time frame, the output is equivalent. 1 hour could have been used to produce 4 tons of granite, or alternately it could have been 12 bushels of blueberries. We do the same thing for Scorpius. For the 1 month, this individual typical worker could have produced 6 tons of granite, or they could have produced 12 bushels of blueberries. So in the time that they produced 6 tons of granite, they could have produced 12 bushels of blueberries. So that those are equivalent to one another. Now what you do is you just want to find out what 1 ton of granite is equivalent to, i.e. in producing 1 ton of granite, how much of blueberry production had to be given up. So 1 ton of granite here, what we do in order to get that is we just divide through by 4 on both sides. We want 1 ton of granite, so it's 4 tons of granite here. We divide the left and right hand sides by 4, and we get 1 ton of granite is equal to 3 bushels of blueberries. We do the same thing for Scorpius. We have 6 tons of granite. We want to divide that by 6 in order to get 1 ton of granite, so we're dividing by 6 through both sides, and we get that 1 ton of granite is equal to 2 bushels of blueberries. So who has the lower opportunity cost? Well, the opportunity cost of 1 ton of granite is equal to 3 bushels of blueberries in Orion, but it's only 2 bushels of blueberries in Scorpius. Therefore, the opportunity cost of production of 1 ton of granite is lower in Scorpius, 2 bushels of blueberries versus 3 bushels of blueberries in Orion. So Scorpius has the comparative advantage in granite production. Since we only have 2 countries and 2 goods, and we have constant opportunity cost in both countries, Orion by default has to have the comparative advantage in the other item. So make sure you remember that if you have 2 countries and 2 items and you have constant opportunity cost, i.e. that you're going to have a straight line for a production possibilities frontier, that once you make the determination of the country that has the comparative advantage in one good, the other country automatically has the comparative advantage in the other good. If we continue with this, now we actually want to use that information to draw the PPFs. Now both countries have 1,000 workers, so if each worker can produce 4 tons of granite, that means that in Orion, if every worker is used in granite production, 4,000 tons of granite could be produced. If we go to the opposite extreme, where all the workers are used in blueberry production, each worker can produce 12 bushels of blueberries. There's 1,000 workers, we multiply that, so it is, if all workers are used in blueberry production, 12,000 bushels of blueberries will be produced in Orion. So that's the PPFO, the PPF for Orion. We do the same thing for Scorpius. Scorpius also has 1,000 workers, and since each worker can produce 6 tons, that means that they can produce 6,000 tons of granite in a month. And because each worker can produce 12 bushels of blueberries a month and there's 1,000 workers, they can if they all produce blueberries, they could produce 12,000 bushels of blueberries. So graphically, we would go to this point here to represent the 6,000 tons of granite that can be produced and the 12,000 bushels of blueberries that can be produced by Scorpius. So this is representing the opposite ends of the spectrum. And let me redo that, redo the line draw. And if I would like to label this, let me actually move this over here so it's a little easier to see. And let me cheat and duplicate that. And this would be the ppf of Scorpius. So if we bring that data back up, that's how we got those numbers. We just multiply the worker productivity per month by how many workers there are. So for Orion, we have each worker is capable of producing 4 tons of granite. There's 1,000 workers. That means that if all the workers are used in granite production, they will be able to produce 4,000 tons of granite. If all those workers are instead allocated to blueberry production, each worker can produce 12,000 bushels of 12 bushels of blueberries. Getting ahead of myself there. 12 bushels of blueberries, multiply that by 1,000. So if all workers are used to produce blueberries in Orion, production of blueberries will be 12,000 bushels. And if we do the same thing for Scorpius, each worker is capable of producing 6 tons of granite per month. There's 1,000 workers. So if all the workers are producing granite, production of granite will be 6,000 tons of granite. And on the opposite end of the spectrum, if all the workers in Scorpius are used for blueberry production, each worker can produce 12 bushels of blueberries a month multiplied by 1,000. And that gives us the 12,000 bushels of blueberries for that end. And actually, I think I can change the color of these. Change that to red. Change that to red. And let me change that to blue and that to blue, so it's just a little bit easier for everybody to see. So that's the beginning part of this problem. I hope that provides everybody with a little help if you're struggling to start with this. In all likelihood, I'll create a separate video that's a continuation of this one.